Showtime. All right, so lesson one. We're going to introduce what is a power. So yesterday, when we were doing our little activity around the class, we kind of looked at some of the components of a power. And so right now, I'm just going to break it down into all of its different pieces, right? So there's basically three things to consider here. So the first thing is our base. And this is what number we're going to be multiplying by itself, okay? Then we have what we call our exponent. Okay, and the exponent's that little number that's above the base. It's much smaller, and so that tells us how many times this number is dividing or multiplying itself. Sorry, not dividing, multiplying. And then everything together is what we call a power. Okay. So for example here, altogether 5 squared is a power. As we explained, the power of 2 is also called squared. So 5 squared, sometimes we talk about 5 cubed, right? If something's times 3, we can make a cube out of that. It is 3 dimensions. And then to the power of 3 is also called cubed, as I just said. Okay, so this is very good when we're talking about area and volume. Okay, so if we want to find the area of a square, we go 4 times 4. And this is the same thing as saying 4 squared. 4 times 4, or 4 squared, is equal to 16. We weren't given dimensions of centimeters, meters, so it doesn't matter. So we'll just leave it as that. Okay, lastly, we can also look at volume. And this is 2 times 2 times 2, which we could simplify. Again, mathematicians, being lazy, we don't want to do all the long work. Especially if we had a number to the power of 100, writing 2 times 2 100 times kind of gets a little boring and monotonous. Sounds like something a teacher in the early years might make you do to learn a lesson, right? So here, if we go 2 times 2, it's 4. 4 times 2 is 8, and that would be our answer. Okay. All right. So we're going to look at a bit of repeated multiplication and kind of what that means. So we can make some nice, easy tables to kind of really break down the components of all the different formats you can write things in. So we have a power. In this power, the base is 2, the exponent is 5, which means we have 2 times 2 5 times. In the end, our answer is 32. Over here, we have 3 to the power of 6, so we end up with the base of 3, an exponent of 6. We can write it in expanded form as 3 times 3 times 3 times 3 times 3 times 3, right? And if you punch that into your calculator, you end up with 729. Okay. The last example I'll do with you guys is here. So we have 4 times 4 times 4 times 4, which is the same thing as saying 4 to the power of 4. So our base is 4, because that's what we're multiplying. It's 4 times, so our exponent will be 4 as well. And if we all do that in the calculator, we end up with 256. Okay, so to simplify your life and make things a little bit easier, we are going to be using our calculators. There's a few different ways you might find how to do a power. The easiest one, if you're doing a number that's squared, there's usually a little button that looks like x to the power of 2. Okay. And so this button on your calculator will automatically square anything. But we're going to be looking at a lot of numbers that aren't squared. They're like to the powers of 10 or 16 potentially. And so we want to find an easier way of doing that than multiplying 4 times 4 times 4 16 times. So one form of calculator might look like, if we're doing 3 to the power of 6, you would punch 3. There's a little one that says y to the power of x. You would hit that button, then 6 being your exponent, and that should punch out your number. Another option you might find is 3, a little like hat arrow up That's saying to the power or an exponent of 6. And then the other one too that you might find is instead of y to the power of x, it's x to the power of y. And on occasion, your calculator, you will find a yellow or some colored button that's different from the rest. Maybe it's green that says second for second function. And it might be like a button like this, but then on top of it, it will have one of these symbols. So if you're not sure how to use your calculator, please come talk to me and I'll definitely help you guys out, okay? If you don't own your own calculator, please go buy one so that you're always using the same calculator, because if you have a calculator that works like this one time, and then this the next time, and then this the third time, you're probably going to be struggling to find those buttons and you're wasting a lot of time. So having a calculator that you know is so important in math and for the rest of your high school and potentially into university or college or wherever you end up. Okay, so go buy a calculator. They're like $16. If you really need it, let me know and I can, maybe rent one out for the year for a low cost of a few sour soothers. So please come talk to me. If you're one of the ones that keeps getting a calculator every class, I'll be coming to talk to you. Okay, so that's all I have for this lesson. The textbook work is listed here, page 97, questions 1 to 9, and we'll see you guys soon.